Hello, viewers. Good day. This is Chetan Kumar HM from the Stiblop Academy and Consultancy. First of all, I wish all of you a very happy New Year 2024. And I take this opportunity to welcome all of you to my channel, Stiblop Academy and Consultancy. Our main intention is to stimulate engineers towards the product mindset. Also, we are here to empower and enable all of you, whether you are an engineer or a non engineer, to create your own product. Okay, so I will just walk you through my channel. Yeah, this is my channel. I hope you might have already watched a couple of my videos before. One is introduction to the product, and another one is introduction to the value engineering. In today's session, I'm going to present in front of you the second part of this value engineering. Okay. Okay, before we go into this session, let's try to recall what we discussed in our previous session. We got to know what is meant by the value of an item, how the value can be increased, and we saw different aspects, how the function can be increased and the cost can be brought down. It was only a brief session, but in today's session, we will go through the value engineering process along with the case study and try to understand how the value engineering process plays an important role in adding the value for any particular item. Okay, case study. Let's try to understand what the scope is. The scope is to simplify the existing design and come up with a value added design, eventually resulting in the cost reduction. What are our learning objectives for today? As I mentioned before, value engineering process, case study, and the conclusion. Okay, okay. Value engineering process. The four phases of the value engineering process are input study phase, idea generation phase, feasibility study phase, and the implementation phase. Let's go through each of these phases one by one. Input study phase. Imagine that you have a device in front of you. First and the foremost thing that we need to do is to collect the BOM and the cost of that particular design or assembly. That is the first step that we do. The next step is the functional analysis of the existing design. Okay. After this, we identify the potential areas that qualify for the value engineering. Once we have identified these, the next thing is to get the cost reduction target input. Okay. The second phase, as I spoke before, is the idea generation phase. So, in the idea generation phase, we, along with the team members, analyze the design and try to come up with as many ideas of as possible which contribute to the cost reduction. Once we have some good number of ideas, we categorize those ideas into different groups, which I will tell you later. Okay. The next phase is the feasibility study phase. The feasibility study phase starts with the continuation of the categorization of these ideas. Once the ideas are categorized, those ideas are described by means of a simple sketches. Okay. Yeah. So once these ideas are described with the simple sketches, we tabulate them in a table and try to calculate what is the cost and how the functionality gets impacted. Okay. After tabulating them, further we have to shortlist those ideas based upon cost versus investment and function versus cost strategy. This I will explain you in much detail when I take up the case study. Okay. Once the ideas are shortlisted from this big bunch, we send them to the next stage, that is the feasibility check evaluation phase. So so we, along with our own team members, check the feasibility of those shortlisted ideas. What are the feasibility criteria? We check whether the how much is the function impacted. We check, is the cost reduction happening with those ideas. We check whether the weight is increased or decreased, and we also check that how reliable and durable our new idea is. Once we have put all these parameters in place, we send it for the SME evaluation. SME is nothing but the subject matter expert team which evaluate our ideas based upon our feasibility check done. Okay, just before the SME evaluation, if we ourselves get to know from the result that our ideas are not feasible, then we completely drop out all those ideas and check the next priority ideas or the next preferred ideas. Okay. So during the SME evaluation stage, the SME team evaluates whether the idea can be approved for the next level. If yes, then we have to calculate the new cost and find the difference between the new cost and the existing cost. Okay. If not, then we have to rework on the feasibility. I mean, we have to improve our design or improve as per the suggestions given by the SME team. And we have to again run through the SME evaluation once again. Okay. Now, imagine that all our ideas are approved by the SME team and we have done with the cost difference calculation. The next step here is to present our V concept to the customer. So, friends, what we observe here is that I am using the word concept. Once this idea gets materialized, we can call it as a concept because the concept is ready for the concept design and development. So, this is a very base level. You will understand this better when I explain you about the product design and development. Okay. Yeah. So, after presenting the V concept to the customer will evaluate our concept and he will either approve it or disapprove it. If he approves that, then the idea moves to the implementation phase. If he disapproves that, then we have to get the reason for the disapproval and seek customer support. Okay. So about the implementation phase, I will tell you in more detail when I take a session on the product design and development. Okay. Yeah. Now moving on. Let's start our case study with the input study first. Yeah. What is the part that is present in front of them? The part that is present in front of them is the door lock. Okay. So this is our traditional door lock, which is having a padlock, lock, and all the supporting brackets. Okay. So the first step is to get the input bomb with the cost. So I have got the input bomb and the cost here. Okay. So the total cost comes to around 1,464 rupees. The next step is to get the cost reduction target. Here, the cost reduction target should be greater than 25%. It means that if our existing um design is 100 rupees, then our new design should be less than or equal to 75 rupees. Okay. Yeah. The next step in the input study phase is the functional analysis. Why should we do the functional analysis? This is very important step because we have to understand the function of each and every part that makes the design or that makes the complete function of that particular item. Okay. If we don't do the functional analysis, if we directly jump into the value engineering phase or the feasibility phase or the idea generation phase, then we may end up into coming up with those ideas where the functions are not adhering with the existing design. So that's the reason doing the functional analysis is very, very important. Let's do the functional analysis of each and every part. Padlock and the rod. The primary function of the padlock and the rod is to connect two doors and hold them firmly for locking it. The secondary function is nil. Okay. Let's look at the features here. The handle should be easily held. Okay. The next feature that we have is this female feature with the slot. Okay. This has to enable us so that the male part of the lock bracket goes inside this one. Okay. Then we have the rod support brackets. The rod support brackets are those brackets which are fixed to doors on both the sides. So the primary function of the rod support brackets is to receive the padlock rod when you move this padlock rod inside them. The main feature of this rod support bracket is that you can see that there is a tapped hole on the behind. Okay, now imagine that this is a door and you are fixing the bracket here. You have to screw from the other side so that even if the thief tries to unscrews from the front, it is held tightly by another screw behind. Okay, so this is the very important feature of this rod support brackets. Next one is the lock bracket. Okay, the lock bracket is the one that receives the padlock locking feature and support the locking, and it is also having the same feature as that of the rod support bracket. Okay, now moving on. Yeah, latch set. The primary function of the latch set is to connect two doors and lock them from inside. Okay, the secondary function is nil. Features. You can see that there is a feature to lock the lever when the door is engaged, and there is also a feature to unlock the lever when it is disengaged so that the rod is not protruded outside. Okay, so we have done with the functional analysis of all these items. Now the next step is that we have to look into the potential areas. So before we look into the potential areas, we have to understand what are the areas to be focused. Okay, the first area to be focused is the material. Now you can see that the plate with the stainless steel coating is around 240 rupees per kg. Imagine that you have an item which is made up of the stainless steel. One of the option could be to change that to the mild steel if the corrosion demands are not so stringent. Otherwise, it will get corroded. Okay, material. So this is just an example. You can have a number of cases like this, where steel part could be converted into FRP part or a composite part because the raw material cost is very, very less for such type of materials. Next one is the integration of the parts. Now, if you look at the water pouring jug to the plants here, there are three parts. The first one is a handle, the second one is a container to receive the water, and the third one is the handle to hold it. So this is not a handle, this is a pouring nose. Okay. So all these three parts can be integrated into a one plastic part like this, which will bring down the cost. And the third area to be focused is elimination of the parts. Friends, if you look at this particular design, this is the design of a simple struss. Okay. Each struss is designed using a formula which is m is equal to 2j minus 3. Here m represents the number of members and j represents the number of joints. We all know this. Okay. Now, if we look at this particular design, the number of members are matching with respect to the number of joints by means of this formula. Okay. Here there are 9 number of joints and the resulting value is 15. So we have 15 members. Okay. The last member is this one. This serves our purpose perfectly. Now, suppose what if I remove these two members, member 14 and 15, and if I apply the same formula to calculate the number of members with respect to the joints, it gives me the value as 13. And this 13 value matches with the number of the members over here. Okay, so this is an example to eliminate the parts. Okay, in this particular case, we can eliminate these two members to get the same desired results. Okay, so here the first case is little bit over designed and the second case is the value engineered design. Commonization and standardization. So one is the LH bracket and one more is the RH bracket. So these are symmetrical. If you combine these two brackets to make into a single bracket, it can just be rotated and used on the other side. This is another area where we can focus on. And the next area is design simplification. This you can see in your day-to-day life. Okay, your kids or your sisters or your brothers might be wearing this complicated shoes, which is having a Velcro design. Nowadays, okay, kids also wear this type of design. Of course, this cannot be wore for the school, but this is not having any Velcro at all. So this is a best example of the design simplification. Okay, yeah. So after understanding all these areas to be focused, coming to our case study, so these are the parts that we have identified that will qualify for our value engineering. Okay, yeah. Now let's go into the brainstorming workshop for idea generation and categorization, and also parallelly do the feasibility check, idea generation and feasibility study phase. Okay, these are the list of the ideas that we came up with. And I was mentioning about the categorization. So we have to categorize them based upon whether it comes in the material group or the common and standardization group or integration of parts or the design simplification group. Okay, fine. And we also have several evaluating parameters like what would be the investment, what would be the cost, workability, reliability, and functionality. Okay. So, friends, from my experience, what I have uh, learned is that the functionality is a function of these two parameters, workability, reliability, and durability. Workability is the capability of that particular item to perform that particular function. Okay. So this is a thumb rule that generally the cost engineers follow. Different cost engineers follow different thumb rule, but the thumb rule that I have followed in my work tenure is this one. This has given the results, friends. If you follow this, definitely you will get the results. Okay. Now let us look at the each idea one by one. Idea one: change of the material from zinc coating to the no coating or the plain mild steel. Okay. So this is the cost. Workability is superb, no problem about this. Okay, but the reliability and the durability is very poor because you can just see the rating here. The reason is during the course of time, this will get corroded and the thief can easily break out this. So the functionality is the multiplication of workability and the reliability and durability. Here it is 5. The next idea is commonization of the support and the lock bracket without changing the inside latch. What I'm trying to say here is, yeah, I want to eliminate this and replace this with rod support bracket. Okay, fair enough. So this also brings cost reduction to some extent, and also functionality is retained. The third idea is the L bracket design without changing the inside latch. So here, this comes under the category of commonization and standardization and integration of the parts. Okay. So here, why I am mentioning the integration of the parts is because here you can see that the lock bracket and the rod support brackets are integrated into a single L bracket. And why I am saying that it is a commonization and standardization, because you can just rotate this L bracket which is there on the left hand side to fit it on the right hand side. Okay. Here the cost calculation that is achieved here is 1,274 rupees. And if we look at the workability here, the workability gets reduced by one rating. The reason is, if you look at this particular design, you have to use a long lock to lock this. And after locking the doors, there is a tendency that this will wobble a little bit. That's the reason the functionality is less for this particular idea, slightly less. And now, moving on to the next idea, where in this idea we have the key operated lever with the latch integrated. Okay, so here this idea comes under the category of design simplification and part reduction. Here the design is very much simplified, and the complete inside latch is integrated into this complete lock. Okay, so here the investment is also medium, whereas for the other idea number three, it is investment is low. Okay, the cost is low as compared to the previous design. However, the functionality remains intact. The next one idea that we have is keyless entry design with the latch integrated. Here, why do I say it as a simplified design? Because it just gets operated with the without a key, and just a moving latch from inside, just one latch. That's it. Okay. Since this is very advanced technology, the cost of this is also very high, but the functionality remains intact. Okay. So this is the result of our brainstorming and the categorization, and also shortlisting. I mean, and also the evaluation of the functionality and the cost. Okay. Now let us do the shortlisting and feasibility check activity here. In the previous exercise, we have done the feasibility check up to some extent based upon the functionality and the cost. In this exercise, we will do a next level feasibility check where we will check those ideas versus our comparing parameters. Okay. Yeah. So our first comparing parameter is the investment versus saving strategy or the cost strategy. Okay. So yeah, I have just given one as a low investment, two as a medium level investment, and three as a high level of investment. So this is the result of the previous table. Zero means no investment at all, because the idea one and two, if you see here, idea one and two, we don't need any investment at all. Whereas idea three, four, and five requires investment. Okay. So idea one, I'm putting that under the first quadrant here. See, 938 versus zero investment. Idea 2 also 1500 versus zero investment. Idea 3, it calls for low investment and the cost is also less as compared to the idea 2. Idea 4, let me bring up the laser. Okay, so idea 4 calls for medium level of investment. Okay, however, the cost is less as compared to all these ideas. And idea 5, I have put it under a very high investment and a high cost. Okay, the next level of the feasibility check that we do here is comparing with respect to function versus cost. Okay, cost is here and the function is here, and I have arrived at the same graph. Okay, idea 1, if you look, the cost is pretty low, no doubt about that, but the function gets reduced. Whereas all the other three ideas, idea 2, 3, and 4, are having a very high function here. Idea 5, of course, it is having a very high function. Okay. Now let's try to shortlist the ideas from these five lot of ideas. It's nothing but filtering. Okay. Now if I look at the 5, idea 5 is an odd man out because the cost is also high, investment is also high, and the manufacturer don't want to go with this idea. So first let me eliminate this. The second one is the idea 1 and 2. If we look at these two ideas, even though the investment is nil, okay, the cost that is getting reduced is a marginal. And why we are not going with the idea 1 is because of the poor functionality. So I eliminate the idea 1. Next, with the idea 2, since the cost reduction is very low here, we don't go with this as well. Okay. Next, coming to the idea 3. So here you can see that the idea 3 is having a low cost as well as low investment, and even the function is also considerably okay. Okay, but idea 4 is qualifying better compared to the idea 3 because of high functionality, and our value calculating formula says that the function should be high even though the investment is high as compared to the idea 3. We can get this investment back during a certain payback period. Okay, so we eliminate idea 3 and shortlist idea 4. So idea 4 is having 838 cost. Okay, and the function is also intact, the function is not at all disturbed, so we go with this one. And what is the result of this exercise? The result is, okay, so the cost of the idea with the existing design, it is 58% of the cost of existing design, and the cost reduction that is achieved is more than 25%, that is 42%. The next step is to review the idea number 4 with the customer. Okay, so we are evident that this idea was approved by the customer and it is successfully running a product in the market. So this Europa lock is liked by most of the customers and which costs only 838 rupees. So thanks to the Europa company for bringing such a value engineered product as compared to the traditional lock. So friends, this is our case study on the lock. Thank you viewers for watching this video. If you have any questions, please put them in the comment box. I will try to answer them. And stay tuned until I put up my next video on some other topic. Thank you.